Hi, welcome to this video about METAL-O-TRON II by Skull and Circuits. METAL-O-TRON II is a module aimed towards making metallic percussion, hi-hats, cymbal crashes, even snare hits, but you can get all kinds of interesting sounds from it, which we will get to in the patch examples later in the video. But the module has a really nice tool set for creating metallic sounds, which is exactly what I want to show you in this extensive playthrough. Thank you, by the way, to Skull and Circuits for sponsoring this video. Before I get ahead of myself, let's first look at the big building blocks of METAL-O-TRON II. First, there's a sound generator section with 4 oscillators that you have level control over here. There's also a noise source. There's also the audio input that you can send anything you want into, and there's also this XOR input that turns everything into square waves. You'll see later in the patch examples that I use this input as an interesting kind of distortion input, but well, you'll see that later. So there's the input section with the 4 oscillators that get XORed together. There's a noise source, and then everything goes through a VCA. The VCA has a built-in decay. There's also CV control over this decay. You can attenuate this CV with the knob here. Then we have a filter. There's the low pass, the band pass, and the high pass. You can engage or disengage all of them. If we switch all these switches to the bottom position, no sound is going through because all 3 filters are disengaged. So it's best to turn on at least one, but you can mix and match these according to your own wishes. The filter also has a CV input for the filter cutoff. There's an attenuator for this CV signal here. Of course, there's also resonance. The filter does not self-oscillate, well, unless you turn it completely down and you start pinging it, but well, it's really not aimed towards making those types of sound. And that is really it. But with those nice building blocks, you can do a lot, really. Let's turn up the sound here. There we have some sound. I'm sending a trigger signal into the trigger input of METAL-O-TRON. This triggers the decay that opens the VCA. There is a short and a long setting for this decay. This is the short setting. You have control over the length of the decay with this knob here. This is the shortest that it can go. Let me slow down my trigger source so we can hear this decay completely. So this is the longest that it can go in the short setting. Let's switch this to long. So this is the shortest that it can go in the long setting. And the the longest that it can go is just, well, very, very long. It's almost like the VCA is constantly open, but that is an option that you have on METAL-O-TRON to open up the VCA entirely by flicking this switch to the bottom position, at which point the decay does no longer have any control over anything that's happening with the volume. If you notice here on the bottom, there's a velocity CV input as well. This reacts to +5 and -5 volts, but if you disengage the VCA like we are doing now, this input has no effect. Let's turn back on the VCA. As I told you, there's CV control over the decay. You'll see if I attenuate this external signal a little bit, it will create more variation. Let's remove this. I have now offsetted this stepped random modulation, and let's send it into the velocity input here on METAL-O-TRON. So you can hear the effect of this velocity CV input. Let's switch to the long decay setting. As you can hear, we can get really interesting and dynamic sounds from this module. Let's have a closer look at these 4 oscillators here. These 4 oscillators are square oscillators. You can tune them by turning these knobs here. If we turn them completely to the right, we turn off the oscillators, so we can turn off all but one. Then we can do a sweep of the frequency range. So this is about as high as it can go. And this is the lowest that it can go. When we turn up more than one, or we send in something to the XOR input, all these sources, all these oscillators are XORed together. XOR is a Boolean logic operation that stands for exclusive OR. What this means is that an output will only be high when one or the other gates are high, but never at the same time. So when 2 of them are high, the output will be low, and this results in really metallic sounds. This operation, this XOR logic operation, is used in a lot of classic drum machines that use synthesis for their hi-hat sounds. So this here is what happens when you use XOR logic on 2 oscillators. The red trace is the result of the XOR logic operation, and I'm using the green and the blue trace as inputs. And you should be able to see that the red trace is only high when one or the other of the inputs are high. You have a level control over these oscillators. This level control also controls the level of whatever we send into the XOR input. And then we also have a level control for a noise source here, which of course is a nice addition if you want to create hi-hats. And if we combine these sound sources, we can really get some metallic sounding cymbal tones. Let's talk a little bit about the filter. As I told you, when you switch them off, there's no sound going through. You can turn on any combination of low pass, band pass and high pass filters. There's an interesting decay mod here that has an attenuverter. What this does is it routes the decay envelope extracted from the VCA section. It routes it to the filter cutoff, which can be interesting for certain types of sounds. And effectively, if you turn this to the left, you invert the envelope. And while the decay parameter has no effect on the volume as soon as you turn off the VCA, the decay for the filter is still active. There's a CV input for the filter cutoff as well. I'm just sending in some stepped random modulation here. You can increase the effect of this modulation by turning up the attenuator for the frequency mod here. You can turn it off, of course, and anything in between. There's also a resonance or feedback control for the filter. It will not go into self-oscillation. Let's turn back on the VCA. Let's send in an external VCO here. Let me show it on the scope here. And we can connect it both to the audio input and to the XOR input. If we turn off all but one oscillators here, you can more clearly hear the effect of the external oscillator. And as you can hear, everything on the module, including the VCA and the filter, is affecting whatever we send into the module, which means that you can use METAL-O-TRON as just a processor for external sounds, which I will show you later in the patch examples. I think you'll agree that you can do a lot of cool things with METAL-O-TRON II that maybe don't sound like hi-hats at all. But you can really quickly just go back to that. In this patch, we're using METAL-O-TRON as something between a synth voice and something percussive. It's a really basic patch, really, but I think it's a fun one nonetheless. I started with 2 oscillators here, the other ones are turned to off. And I have the bandpass and the high pass filter engaged. And I remove the modulation for the filter cutoff. You can hear how that sounds without the modulation. So this is the decay mod. This follows the decay of the VCA and applies it to the frequency of the filter. So when we turn this to the left, we invert the envelope. And you can hear that we are getting kind of a moi sound. So I just set it to a little bit left of the center here. The decay is set to short, the VCA is obviously on, and there is some modulation going to the decay of the VCA as well. This modulation is coming from a stepped output of a nibbler, which is also used to trigger all the voices in this patch. So we can turn up the decay manually. As you can hear, there's also a little bit of noise in there. If I turn it up, you can hear it better. At this point, it's barely noticeable, but I like how it's a little bit in there. You will notice it when I turn it completely down. Just a tiny bit. Let's connect the CV signal to the decay once again. We can increase or decrease the effect of this modulation of the decay with the decay CV here. I like it like that. Then there's a stepped random that I had connected to the filter cutoff just for a little bit of variation. We set the sensitivity of that control here. Let's bring in the other sounds of this patch. I'm sequencing all of this. Well, the trigger and the triggers are made by Nibbler, but the sequences are made with a Leo matrix programmer by Vox Machina. In this patch I'm using METAL-O-TRON for everything that you find in a classic subtractive voice. There's one external oscillator patched into the audio input, but I'm also using one of the built-in oscillators. The VCA is turned off. When I turn it on, you can hear that it responds to these triggers, but even when I turn it off, which means that the VCA just stays open, you can hear that there's some kind of ducking going on, and this is because this knob here for the decay modulation is turned to the left. This inverts the envelope and uses it for the cutoff frequency of the filter. This way I'm able to get this ducking effect. There's a little bit of white noise, well, there's quite a lot actually, but because I'm using the low pass and the band pass output, or sections rather, it's hard to hear. When I briefly switch to the high pass, you can hear the noise in there much clearer. All of these combinations are pleasing to my ears, but let's go for that. The VCO that I'm sending in is a triangle wave. I'm sequencing this triangle wave with the Leo matrix programmer. By routing it through METAL-O-TRON, you can use the built-in filter on METAL-O-TRON and the VCA to shape this VCO together with the built-in VCOs. I'm just using one. This means that there is no ringmod going on. This would of course change if I use the XOR input here. This XORs with everything else that's already being XORed. In this case, it's just one square VCO. And let's bring in a few other sounds here. If we look past the wires here, you can see the green trace on the scope, which is the audio output of a mixer. This is actually what we are listening to. The red trace is the output of METAL-O-TRON, but nothing is happening on the module yet. As I explained in the introduction about this module, you can use the XOR input as kind of an interesting distortion, and I want to run this mix through that input. So let me patch that up. And you can see on the scope that when you send something into this input, the module tries to make square waves out of it, which results in this nice sounding distortion. Currently all the filter sections are engaged and there's no resonance, so the audio is, well, the XORed audio is kinda just going through the module. You can degrade this signal even more by bringing up the noise. I really like how this sounds. Let's take out the bandpass and do a sweep. This is lovely. Of course you can modulate this movement with anything you want. I'm using a looping envelope here where the filter cutoff input is here. Now ideally you might want to sync this movement to the original patch. Let's take out the high pass. Let's bring up the resonance a bit. Of course, instead of doing this with an external envelope or LFO or whatever, you can still just use the trigger input on the module. And then when I, for example, turn on the VCA, we get this gated effect. Well, there's an envelope applied to the amplitude. We can also apply this envelope to the filter cutoff. Let's bring in the bandpass. We can invert the envelope. And even with the VCA off, you can still use this movement of the filter. I think this is really lovely. Let's remove the noise here. You can bring in the other VCOs, well, the built-in ones, but you can hear they are quite overpowering. But you might find interesting sounds nonetheless. Yeah. So you can use the XOR input as a really cool distortion, at which point the Metal-O-Tron becomes kind of a sound shaping, sound design degrading tool. Really nice. I made this patch out of pure curiosity. I wanted to see if I am able with Metal-O-Tron to get it to play a full drum groove. Of course, I had to send in some clever modulation to achieve this, but all the sound that we are hearing is coming from this single audio output of Metal-O-Tron here. The first thing I did was find the frequency where we get a nice thumping pinged filter by turning up the resonance and turning down the cutoff frequency. I was able to do so. And then if we increase the filter cutoff for all the other steps, we're not going to get kick drums on those. So simply by modulating the frequency of the filter, we're able to achieve this on Metal-O-Tron. For the snare drum, I sent in an offset that is a little bit less high than the offset for the hi-hats. I'm using the bandpass filter, by the way. So the kick drum has a frequency tuned very low, and the snare drum is like somewhere in the middle of the frequency range. And then for the hi-hat parts, I sent in a very big offset of 10 volts. I also modulated the decay. I modulated it to be very short, so no offset on the hi-hats. But I sent in a very high, I think almost 10 volts offset for the kick drum parts and the snare. And because the hi-hats are so much louder than everything else, I also modulated the velocity a bit, which seems to have a limited effect in this particular patch. So So this right now is the audio output of METAL-O-TRON going through the clipping part of Collide 4. I'm not using any of its shenanigans. I just wanted the levels of the separate instruments, kick drum, snare drum, hi-hat, to be a little bit more even. So a clipper is nice for that. I also added in this bass part. By the way, we have the decay set to short. We can set it to long. I think that works equally well. In this patch I just want to use METAL-O-TRON for hi-hats, probably the thing that most people associate with this module. I'm sending a swung or shuffled trigger into the trigger input of METAL-O-TRON. The green line on the scope is modulation going to the velocity parameter here. And then the red trace that sometimes goes high, and then it's just a gate, really long gate. This modulates the decay parameter. So the thing going into the decay parameter is always 5 volts. There's no variation there. So either the decay is going to be short, or it's going to be modulated to be open. And I turned the decay CV knob here completely to the right, so the effect of those 5 volts is the maximum that we will get on this module. Of course, changing to the short decay well, has a big effect. This, of course, is to mimic a closed hi-hat and an open hi-hat. I'm going to turn the parameters a little bit. I'm going to tweak the module while we play the patch. Let me first bring in the other sounds. This is a kick drum, obviously. There's a snare drum. There's then 2 additional snare drums panned left and right. And I also made this synth to go with it. Maybe I should turn these down a little bit. Be sure to listen on good headphones in stereo. I really like the stereo movement in this patch. Let's just tweak around the parameters on METAL-O-TRON to find a few interesting sounds here. And this is going to be it for this video about METAL-O-TRON II by Skull and Circuits. The build quality of this module is very good. The pots don't wiggle or wobble at all. The switches feel nice. As a metallic percussion generator, I'm really pleased with how this module operates. It serves that purpose very well. But what I like even more is that you can kind of abuse it for other kinds of things, as I showed you in the patch examples. And I'm sure you can figure out cool and interesting ways to abuse this module as well. I hope you enjoyed this video. I also hope you learned something. Thank you very much for watching. See you next time. Bye.